Welcome to the channel, dear students. So in this video we will be covering a very important theorem, that is image theorem and foot of the perpendicular theorem from straight lines. Okay, so the first question or the first theorem is, if q h comma k is the foot of the perpendicular from b x1 y1 onto the straight line ax plus by plus c equals to 0, then we need to prove that h minus x1 by a is equals to k minus y1 by b is equals to negative of ax1 plus by1 plus c divided by a square plus b square. So the proof is very simple. So let us first try to draw the diagram. So he has given that we need to find the foot of the perpendicular from P onto the straight line. What does foot of the perpendicular mean in first place? If I draw a line perpendicular to the given line, that is ax plus by plus c equals to 0, passing through P, wherever the line meets the given line, the point of intersection is nothing but the foot of the perpendicular. So the line should be a perpendicular. Now the coordinates of q are h comma k, right? So we need to first find the slope of PQ. So slope of PQ can be found by using the formula y2 minus y1 by x2 minus x1. So that will be k minus y1 by h minus x1. So that is the slope of the given line PQ. Now let us find the slope of the other line, that is ax plus by plus c. So that will be negative of a divided by b. Now when two lines are perpendicular, the product of the slopes is equals to minus 1 if two lines are perpendicular. So based on this, can we write k minus y1 by h minus x1, that is m1, and m2 is negative of a divided by b. So this should be equals to minus 1. We can cancel minus and minus on both sides. Now let me write k minus y1 by b and a by h minus x1 separately. Now let us send this part. Let us send this part to the right hand side. So we get k minus y1 by b is equals to h minus x1 by a. Now when two ratios are equal, we can equate that to a constant, let us say lambda. Now if I equate these two, so we can say h minus x1 by a is equals to lambda, h minus x1 is equals to a lambda, h is equals to x1 plus a lambda. So this is one quantity. Now similarly, if I equate these two, we get k is equals to y1 plus b lambda. I hope you understood this. Try equating these two, we will be getting k equals to y1 plus b lambda. Now q of h comma k lies on this line ax plus by plus c equals to 0. That means we can replace x with h and y with k. So we get ah plus bk plus c equals to 0 since q lies on the given line. Now what is h? H is nothing but x1 plus a lambda and k is nothing but y1 plus b lambda. So ultimately we get ax1 plus a square lambda if I multiply a with this, and if I multiply b with this, I'll get b y1 plus b square lambda plus c equals to 0. Now let us separate this term and this term. We get ax1 plus by1 plus c, and from the remaining terms, if I take lambda common, I get lambda times a square plus b square equals to 0. Now let us send this term to the right hand side. So we get lambda into a square plus b square is equals to negative of ax1 plus by1 plus c, and therefore we get lambda is equals to negative of ax1 plus by1 plus c divided by a square plus b square. Now let us substitute lambda in equation 1. So we get, therefore we get h minus x1 by a is equals to k minus y1 by b is equals to negative of ax1 plus by1 plus c divided by a square plus b square. Hence proved. That's it. So the theorem is as simple as that. Now let us prove the next theorem, theorem number 2. So theorem number 2 says, if q h comma k is the image from x1 y1 from p x1 y1 onto the straight line, then we need to prove that h minus x1 by a is equals to k minus y1 by b is equals to minus 2 times ax1 plus by1 plus c by a square plus b square. So the difference between this theorem and this theorem is that in the formula we have -1 here and here we have -2. So the proof is very simple and very similar to the previous theorem. Now again let us try to draw the diagram. So P x1 y1 is the given point. Now we need to find the image of P with respect to the line. So now image is Q h comma K. And what is so special about this point M? M is the midpoint of P and Q. That's how object distance is equal to image distance, am I right? And again the given line is ax plus by plus c equals to 0. So the initial part is the same. Again we will try to find the slope of line PQ, that will be k minus y1 by h minus x1. Again we will try to find the slope of the given line, that will be negative of a divided by b, and once again m1 m2 is equals to -1 since PQ is perpendicular to the given line, and then k minus y1 by h minus x1 into minus a by b is equals to -1. We can cancel minus, and again we get the same thing, that is k minus y1 by b is equals to h minus x1 by a, and let us again say this as lambda. So till here the proof is the same. So in the previous theorem we replaced x and y with h comma k since q lied or q lies on the given line. Now in this theorem q does not lie on the given line, and what lies? M lies. And how do we get the coordinates of M? M is nothing but the midpoint of P and Q. So how do we find the coordinates of M? That will be x1 plus x2. x1 plus x2 divided by 2. So that is x1 plus h divided by 2. Similarly y1 plus k divided by 2. Now M lies on ax plus by plus c equals to 0. So again we replace x with this particular thing, that is x1 plus h divided by 2, and we replace y with this particular thing, so we get y1 plus k divided by 2 plus c equals to 0. So if I multiply the first term with a, I get ax1 plus ah, and the second term let us multiply with b, I get by1 plus bk, and let us take LCM. So the LCM is 2, so 2c, denominator we get 2. Now let us club this term and this term. So we get ax1 plus by1 plus 2c, and then we have ah plus bk equals to 0 since 2 into 0 is 0. Now we need to replace h again from these two. If I equate these two, h is again x1 plus a lambda, and if I equate these two I get k is equals to y1 plus b lambda. Now I have to replace h and k with this particular quantity, so I get ax1 plus by1 plus 2c plus a times x1 plus a lambda plus b times y1 plus b lambda. I am replacing h and k with these particular quantities. So if you carefully observe, I have one ax1 and from here I get another ax1, so I get 2 ax1. I have one by1 and from here I get another by1, so if I club I will be getting 2 by1, and I have one 2c, and now I have to multiply these two, I'll be getting a square lambda, and if I have to multiply these two I'll be getting b square lambda. So if I take 2 common from these three terms, I get 2 times ax1 plus by1 plus c, and if I take lambda common I'll be getting a square plus b square equals to 0. Now on rearranging, if I send this term to the right hand side, I get lambda times a square plus b square is equals to minus 2 times ax1 plus by1 plus c. Therefore lambda is equals to minus 2 times ax1 plus by1 plus c divided by a square plus b square. Now we have to substitute lambda in equation 1. So we get h minus x1 by a is equals to k minus y1 by b is equals to minus 2 times ax1 plus by1 plus c divided by a square plus b square. That's it. Hence proved. So thank you for watching this video. Meet you with the next one.